A vector is a quantity that has magnitude and direction. In one dimension, we show the direction of a vector by a plus or a minus sign. However, in two dimensions, we show a vector by an arrow with lengths proportional to the vector's magnitude and pointing in the direction of the vector relative to some reference frame. So let's say this is our coordinate system, and this is the vector A. So the length of the vector is the magnitude, and the angle it makes with the reference frame, for example, relative to the x-axis, it's the direction. The head-to-tail method is a graphical way of adding vectors. The tail is the starting point of the vector, and the head is the final pointed end. So this is the tail, and this is the head. To find the sum of two vectors using this method, first we draw the first vector. Next, we draw the second vector, placing the tail of the second vector at the head of the first vector. So let's see how that works. Let's say I have a vector A and a vector B. So I draw vector A, and then I place the tail of B at the head of A. And if there are more than two vectors, we continue this process for each vector. Finally, we draw an arrow from the tail of the first vector to the head of the last vector. So, like this. And this will give us the resultant or the sum of the other vectors. The length of this resultant arrow will give us the magnitude of the sum, and the direction is the angle it makes with the reference frame. Vector subtraction is an extension of vector addition. To find subtraction of a vector from another, we can simply find the sum of the first vector with the negative of the second vector. So let's say I have vector A and vector B, and I want to find A minus B. I can simply say A minus B is the same as A plus negative B. But what is negative of a vector? The negative of any vector is a vector with the same magnitude in the opposite direction. So if this is B, this would be negative B. To find the sum and subtraction of vectors graphically, we would need a ruler and a protractor to do the measurements on paper. The accuracy of this method is limited and depends on the precision of our drawing and the measuring tools. This brings us to the analytical method of vector addition and subtraction. When summing two vectors using the analytical method, we often separate vectors into their perpendicular components. For example, if we have a vector A, this would be the x component, and this would be the y component of the A vector. Please note that AX, AY, and A together form a right triangle. So if I draw AX here, and then I draw AY here, AX plus AY gives us A. And this is forming a right triangle. Now let's say A forms an angle theta with the x-axis. Then we can say the following relationships hold for AX and AY. Note that the relationship AX plus AY equal A, this is only true for vectors of AX, AY, and A. Now that we learned about x and y components of a vector, and we learned the relationship between them, let's use the analytical method to add two vectors A and B. So first, I'm going to show A and B in a coordinate system. Let's say this is our vector A, and this is B. I'm going to draw the x and y components of A and B. Now, from the graphical method, we know that the resultant vector is this. Now I'm going to draw the x and y components of the R vector. As you can see in this graph, the sum of y components of A and B gives us the y component of the resultant vector, and sum of x components of A and B gives us the x component of the resultant vector. To calculate AX and AY and BX and BY, we use the formulas that I just mentioned here. Once we find the x and y components of A and B, we add them up to find the x and y components of the resultant vector. And then after we find the Rx and Ry components, we can use the Pythagorean theorem to find the magnitude of R. And we can find the direction of R by finding the angle it makes with the x-axis. Now let's look at an example. Let's say A is a vector with magnitude 53 meters forming a 20-degree angle with x-axis, and B is another vector with magnitude 34 meters forming a 63-degree angle with the x-axis. And we want to find out what is the sum of these two vectors. So let me draw these two vectors in a coordinate system first. And we want to find the sum of A and B. This is very simple. You just need to use the formulas we learned and carefully substitute the numbers in those formulas. So let's find AX and BX first. And then let's find AY and BY. Now that we have AX and BX and AY and BY, it's time to find RX and RY, and then we can find the magnitude of R. Note that, so far, we have only found the magnitude of the vector r. To find the direction, we have to find the angle it makes with the x-axis. Okay, so now we have both the magnitude and the direction of the resultant vector. I hope this video helped you learn the graphical and analytical methods of vector addition and subtraction. If you have any questions, let me know in the comments, and don't forget to subscribe so you don't miss my next video on projectile motion.